Well, hello, grade 12s. Welcome to the next lesson um, in Spiral 4. We're looking at lesson 6, so we're really getting into the home stretch here um, for the final days uh, of the course. We're going to talk about rational exponents today. So our goal is to write and evaluate rational exponents in more than one way. So exponents is, well, I know it's not everybody's favorite topic. And rational exponents, now we're talking about exponents that are fractions. So it could be that it's really not everybody's favorite topic, but let's see if we can take a little bit of the mystery out of it. A rational number is any number that can be written as a fraction, where the bottom isn't zero, and a and b are integers, so any fraction. Now, recall when we had 3 times 3 times 3 times 3, that meant 3 to the exponent 4. But 9 to the 1/2, what the heck does that mean? We have half a 9 multiplied together? That doesn't mean anything. It does not mean 9 times a half. Okay, let's make that really clear right now. What it actually means is that it's a root of 9. And in this particular case, it's a square root of 9. Most of the time we don't write a 2 in there. But it means what number do I have to multiply by itself 2 times to get to 9? So the answer there is 3. So what's it mean if we've got something to the 1/4? Well, 1/4 is the same as the 4th root of something, in this case 16. So it means what number do I have to multiply by itself 4 times to get to 16? So that would be 2 times 2 times 2 times 2, or just 2. And 8 to the 1/3, well, that means that it is the cube root of 8. And it's asking you what number do I have to multiply by itself 3 times in order to get to 8? 3 times. In this case, that's 2 as well. 2 times 2 times 2. So when you see a fraction as an exponent, the denominator of that fraction tells us what root it is. Now, if you're going to plug it into your calculator, you're looking for one of these buttons. It's either going to look like a little up arrow, it's going to be y to the x, x to the y, or this button. So same as the buttons that we've been using all along for any kind of exponent. So when you plug it in, you're going to plug in 16, then whatever the button is, one of these ones, and then make sure that you use brackets. This is really important to make sure that you use brackets to get the fraction as the exponent. If you just put to the exponent 1 and then divide it by 4, what it does is goes 16 to the exponent 1 divided by 4. And that's not what we want. We want 16 to the exponent 1 over 4. So make sure that you put these brackets around there when you plug it into your calculator. So give this a try. Make sure that you can actually get a 2, because that's what you're looking for here. You're actually looking for a 2 when you plug that in. That just makes sure that you've plugged it in correctly. So these ones say evaluate without using a calculator. So I want you to think about it. What exponent do I have to put, or what do I have to multiply by itself 5 times in order to get 32? Well, the answer to that is 2. Another way of writing this would be 32 to the root 5. You might find a button like that on your calculator as well, but it's probably just as easy to use the exponent button. 81 to the 1/2. Remember, that's the square root of 81. If you know that's the square root of 81, that makes this one really easy. It's just 9. 81 to the 1/4. That's basically a square root of a square root. What do I have to multiply by itself 4 times in order to get 81? So it's the fourth root of 81, which is 3. 3 times 3 is 9, times 3 is 27, and then times 3 is 81. And then this one here, what do I have to multiply by itself 3 times in order to get 125? Well, anything that ends in a 5, you should be suspicious that it might be 5, and that is what it is in this case. 5 times 5 is 25, and then times 5 again is 125, so the cube root of 125 is 5. Now this says, using your calculator, calculate to 2 decimal places. So these are not going to be nice ones. So we need the calculator. So I'm going to pull up a calculator here. And hopefully it'll work similar to what you've got there. The exponent button on this calculator looks like y to the x, which is right there. So on my calculator, I'm going to type in 10 to the exponent, and then I'm going to use the brackets and do 1 divided by 2. Mine even looks like a fraction when I'm done doing it. Yours probably won't on your calculator. And I'm going to press equals. And it asked to 2 decimal places, so 3.16. 3.16. Let's do the next one. 81 to the 1/3. 81 to the exponent, bracket 1 divided by 3, end bracket. 4.3. Now this is 2/6. Please make sure that you're rounding appropriately. So if I'm rounding to 2 decimal places, this 2 is going to have to move up to a 3 because the next one is higher than 5. So 4.33. And the last one on here that we're going to do with the calculator is 14 to the 1/5. So 14 to the exponent, whoops, that's not 14, that's 144. 14 to the exponent, bracket, oh, I got too many brackets. 1 divided by 5, close bracket. And that's, now this is another one we have to be careful of rounding. So this is a 9, but the next thing says round it up. So it rounds to a 10, this rounds to a 7. So this is 1.70. Okay, now these ones just say rewrite in root form. So all I want you to do is say what the equivalent is, and you don't have to go any further than that. It's not asking you to punch it into the calculator. So this is the cube root of 5. This is 18 is our base, and it is the 5th root of 18. And that's really all there is to it here. Now, why would we need this? Well, sometimes we may need to actually solve for something. So we have to think about the opposite operations. So the most useful aspect of rational exponents is using them to solve equations with exponents. So the opposite of squaring is square rooting, and the opposite of square rooting is squaring. Well, same thing with anything that's a higher root. The opposite of cubing something is cube rooting. The opposite of taking the 4th power of something is taking the 4th root of something. So roots are the opposite of powers. So in this case, if I want to know what x is, I have to do the opposite operation. This is a square root. To get rid of it, I have to square it. And you have to do the same thing on both sides. So when you get rid of it over here, that's just going to be an x. And 25 squared is 625. Now over here, the opposite of cube rooting is cubing. So to get rid of that, we're going to cube both sides. So this is just going to be x because I got rid of it. A third times, remember this is a power even, so a third times 3 is just 1. And 4 to the exponent 3 is 64. This one down here, we're going to raise it to the 6th power on both sides. To get rid of 1/6, we raise it to the 6th. So that's going to be x, and then 3 to the exponent 6 is 729. Over here, raise it to the exponent 5. So I get just an x over here, and 2 to the exponent 5 is 32. Now, going back the other direction, if I know that I have x to the 5th, to get rid of a 5th, I have to raise it to 1/5. And you need to do that on both sides, to the exponent 1/5. So then you plug that into your calculator. Here, I'll let you see me plug that one in my calculator. 32 to the exponent, bracket 1 divided by 5, close bracket. It's just 2. And x to the exponent 3, we're going to take 1/3 of x to the exponent 3. Whatever you do to one side, you got to do the same thing to the other. So this is just going to be x here, and 102 to the 1/3. 102 to the exponent 1 divided by 3 is about 4.7. I hope that's pretty straightforward, because that's it. So you've got your homework to look at. Please make sure that all the work is done from the last few days. That was the optimization problems for area and perimeter and volume and surface area. So if you haven't done that, make sure that that gets completely finished before the end of the period today. And hopefully I'll be back with you tomorrow. Bye.